Okay, today we will cover trajectory planning. So your topic for your OBE1, Open Book Exam 1, will cover DH method and trajectory planning. So these two topics will be asked in OBE1. So you can focus for OBE1 on DH method and trajectory planning. So trajectory planning is not so difficult topic. So you just calculate your velocity, position, velocity, and acceleration. So they have joint space scheme. So you have three type of trajectory planning, which is cubic polynomial, higher order polynomial, and linear function with parabolic plan. So there are three space scheme. Okay. So trajectory planning introduction. So what is trajectory planning? Time history of position, velocity, and acceleration for each degree of freedom of a robot arm. So if you want to manipulate your robotic arm, for example, in this example, so you want to manipulate for example, this is a chicken egg industrial. So you want to move the product to, for example, this is red line. So one motion of your robotic arm, the blue one is the other motion. So the green is the third motion. So the motion that you control your robotic arm, you're going to control your velocity, your position, and also your acceleration. The formula that we use is a trajectory planning. The trajectory planning of robot trajectory from one location to another in control manner. So because you don't want to move your robotic arm a lot of stoppages, or you want to move your robotic arm in a smooth motion, so that means we need to control the velocity, we need to control the acceleration of the robotic arm. So one of the technique that we use to control that characteristic of motion by using trajectory planning equation. So this example of block diagram of control system for trajectory planning. So motion control system, this is your robotic arm, and then you have a feedback from your sensor encoder to measure your position, velocity, acceleration, go back to your motion control system to control your actuator, your robotic arm. Okay, when we use trajectory planning, we can control your robotic arm in a smooth motion and continuous motion. So, and also you have ability to include intermediate or via point. That means if you have any position or any obstacle in your motion, so you can avoid by controlling your velocity in a smooth manner lah. smooth motion lah. And when we do a manipulation, robotic arm, so we have two different approach. One we call joint space scheme, and the other one is Cartesian space scheme. So joint space scheme or point to point planning in joint space, each joint is required to move from initial to final position. Later I will explain what is initial, what is final position. Intractable and effector trajectory. Example motion of joint space scheme is a pick and place motion. Cartesian, planning in Cartesian space, and effector motion is control, observable and effector trajectory. Example of Cartesian space is a welding process. Okay, joint space scheme, trajectory of each joint is specified in terms of joint angle by inverse kinematic. And then smooth function is planned for motion from initial to final angle for each joint. Time required for each joint is the same. Okay. Okay, this is an example of trajectory planning using cubic polynomial. So the main equation of this cubic polynomial is this one, equation 1. So theta A0 plus A1, T is a time plus A2 times square plus A3 times power of 3. Okay, this is position equation. Position equation. So consider one joint move from theta. Okay, theta 0 is initial. Some book they say initial, some book they say starting point. This final theta final is a final point or goal point. Okay, based on this main equation, if we differentiate once over time, so we will get velocity. So distance or position, differentiate with time, that means you get meter per second. So you will get velocity. If you differentiate twice over time, so this is time, you differentiate twice, so you will get acceleration. So if you differentiate once with time, then you get velocity. If you differentiate twice, you will get acceleration. Okay, from this equation, you will get some value based on the condition given. So for example, at theta time 0, position, this is position. This is theta 0, this is theta final. That means your position, your angle of your robotic arm. theta 0, and this is theta final. This is time 0, this is time final. That means this is your time that your robotic arm manipulate the object or move between starting time, starting position or starting time to your final position or final time. So this is your time taken for your robotic arm to move. So at theta 0, at position 0, so you know that theta equal to 0. At theta 0, sorry, at time 0 equal to theta, and then at time final equal to position final, theta final. And then you also know that velocity at theta time 0, velocity is 0. So this is facts that before you move anything, so your velocity is 0. This one dot is velocity. If you have two dot, that's mean acceleration. So at time 0, position at time 0 is equal 0 second, is equal 0. And then theta at time final, so your velocity at time final or goal position is also 0. So when your robotic arm stop, so this is start velocity is 0. And then when your robotic arm stop, so stop also your velocity equal to 0. This one position at time 0 equal to theta 0. And then your position at time final, your theta equal to theta final. So this information you will get from the equation, from this equation, before you start anything of your manipulator. This is example is the velocity lah. Velocity sure before you start is 0, after you stop is 0 velocity. This one, if you forgot, so I can refresh back your mathematics differential equation. So if you differentiate this equation, so a t power of 0 equal to 0. 0 multiplied by a0, so your a0 is gone. So you can cancel. So t power of 1, so 1 you put in the front, multiply with a1, so t1 minus 1 is 0. So you got a1. So 2 put in the front, you get 2a2. T power of 2 minus 1, you get t. And then this 3 put in the front, so 3a3. T 3 minus 1 equal to 2. So this is the equation for velocity. And this equation for acceleration, similar to the velocity formula. So once you differentiate again with time, so your a1 cancel out because t power of 0 is equal 0. So you can cancel out. This is t power of 1. So you get 2a2. And then t power of 2, you put 2 in the front. So you get 6. 2 multiplied by 3 is 6. A3 power of 1. T2 minus 1. So T power of 1. Or you can write down T lah. T power of 1. Okay, for equation, combining position, velocity equation, and all constraint, we have theta equal to A0. How we get this? Okay, at time 0, when your T replaced with 0, so this one, T replaced with 0, so you only have left is A0, A0. So you left only A0. Position 0 equal to A0. At time equal to 0 lah. Time equal to 0. That's mean you not move. Your robotic arm didn't move yet at starting point or initial point. So your time equal to 0. When time equal to 0, so you replace T equal to 0, 0, 0. So you only left A0 at theta 0, so equal to A0. And then at theta final, the other one is okay, theta final. So you will get this equation because your time is not 0. So you left your equation this as this. And then this is A1 equal to 0. So this one is at velocity. Velocity 0 equal to A1. And then this one equal to this equation. So 4 equation with 4 unknown and all variable could be solved. Okay. So this is the longer calculation. So you can define cubic polynomial using this formula. So this is the faster way to solve your cubic polynomial. So at position 0 equal to A0, velocity A1 equal to 0. By solving this equation, this is velocity. Velocity at initial. This is velocity at final. So initial, when velocity 0, so you get equal to A1. So A1 equal to 0. A0 equal to theta 0. And then A2, to find A2, because you need to find A0, A1, A2, A3. So to find A2 and A3, so you will use this formula. So use this formula. So theta final minus theta 0. Theta 0 is starting or initial. T power of 2 final. So time final, then you need to power of 2. To find A3, you put a negative 2 over T power of 3, T final, power of 3. So then the angle is theta final to theta minus theta 0. So if you use this formula, you can easily find out your A0 until A3. This the number example in numeric or number. For example, in exercise 1, a single link robot, single link, so only one arm robot, single link robot with a rotary joint is motionless at theta equal to 15 degrees. It is desired to move the joint in a smooth manner to theta 75 degree in 3 seconds. Find the coefficient of a cubic that accomplish this motion and bring the manipulator to rest at the goal. Plot the position, velocity, and acceleration of the joint as function of time. Okay. So the word they use here is motionless. Motionless means initial. So starting from motionless. Motionless means that you start from starting point or initial point. So you start at initial point, but theta is already 15 degree. Not start from 0 degree, but starting at 15 degree. That means your robotic arm is not start from 0. It start already 15 degree. It is desire to move joint in smooth manner. Okay, smooth manner because we use trajectory. Trajectory is the function to move your robotic arm in smooth manner. So move to 75 degree. 75 degree is your final position. Some they call goal position. Final. In 3 seconds. So that means you start from 15 degree, move to 75 degree in 3 seconds. Find the coefficient of the cubic that accomplish this motion and bring the manipulator to rest at the goal. So you need to find to plot a position, velocity, and acceleration of the joint as a function of time. Okay, I need to draw. If not, it's difficult to understand. Hold on, I need to draw. You need to find a coefficient value for trajectory using cubic coordinate. It's not so difficult. Okay. Okay, so the question said that you have one single link robot manipulator. So you have one robot here, single link. Okay, so your theta yeah, this is 0 degree. Yeah. So your robot motionless at 15 degree. For example, this one 15 degree. Yeah. So this is 15 degree. Is desire to move the joint in a smooth manner to 75 degree. This is theta. So you want to move 75 degree in 3 seconds. That means you want to move your robotic arm from here to here in 3 seconds. How you going to control from not from 0, from 15 degree, from 15 degree to 70 degree, sorry, 75 degree in 3 seconds in a smooth motion, in a smooth motion. So that means starting from 15 to 75 in a smooth motion, including velocity and acceleration. That's come out robot trajectory planning using cubic polynomial. So you want to make sure that your motor here start rotate is not immediate, we call stoppages or immediate starting. So you need to control your velocity from slow until high speed, and then from the high speed you want to stop. You not immediately stop. You need to slow down your velocity until your robotic arm stop. So this we call smooth motion. Smooth motion. So to get this type of motion, so we need to use trajectory planning. So this is example graph of position. This is position. If you see this graph, I make it bigger. So you can see this is your motion. So all this motion is in 3 seconds. So that means, so you want to move from 15 degree to 75 degree in 3 seconds. So your graph, X graph will be 3 seconds. And then this is your position. So you want to move your robotic arm from 15 degree to 75 degree. So this is 15, this is 75. So you want to move from 15 to 75. This is the graph of your position. So you want to move from 15 to 75. And then this is your graph for your velocity. So you cannot drastically start your motion because that one is not smooth. So we need to run or to move your robotic arm in smooth manner. So we need to increase the velocity in a smooth motion. It's not immediately jump into the high speed, high velocity. So we need to move slowly until we reach the maximum velocity in the middle, and then change the velocity slower and slower until we reach the final position. So, and then this is the acceleration in 3 seconds. So from start, so your acceleration at 0, your acceleration is high, and then reduce your acceleration, reduce at your final duration, final position. How to get this value? So to get this value, we need to use back our main equation just now that we used. So you must remember this equation because this is the main equation. If you use this, so you must remember the main equation. The rest you can apply voltage differential. You can use differential formula to get the velocity and the acceleration equation. So the important you must remember or you must apply is your position equation. Theta time A0 plus A1t plus A2t plus A3t power of 3. Then if you at theta equal to 0, the time equal to 0. So time equal to 0, that means at this point, time equal to 0, and this is time equal to 3 seconds. When time equal to 0, so this one can be cancelled. So at theta 0 is equal A0. Sorry. Coefficient. So A0. If time equal to 3 seconds, so theta equal to 3 seconds. So your time equal to 3 seconds, so you get A0 plus 3A1 plus 3A2 plus 3 power 3, 27, A3. 27, A3. At 3 equal to, theta equal to, time equal to 3 seconds, sorry. Time equal to 3 seconds. Same go to the velocity. This is position. Your robotic position. So the absolute value you can get here, and then your velocity, what value or equation you can get from this main equation. So at t velocity, theta dot is velocity. Velocity time equal to A1 plus 2A2t plus 3A3t power of 2. So at velocity, at starting point, okay, starting point, so your time is 0. Velocity also 0. So at velocity, at time 0, So this one you can cancel. So equal to A1. Then at velocity equal to 3 seconds, then you just replace T equal to 3. So equal to A1, 3 multiplied by 2 is 6. 6 A2 plus 3 power of 2 is 9. 9 multiplied by 3 is 27. Okay, and the other one, the equation, this is for velocity. This is a longer way lah. If you apply, you're going to find acceleration. So acceleration equal to, if you go back to the equation, go back to main equation. Okay, this one. So double dot is your acceleration. If your acceleration at 0 time, so we see what happened to the equation. 2A2 plus 6A3. So at acceleration at time 0, so this one can be cancelled. So 2A2 and acceleration at time equal to 3 seconds. 3 seconds. So 2A2 plus 18 A3. So you have 3 equations now. Some equation you already have the value. So this is equation 1, equation 2, and this is equation 3. So this one, theta 0 equal to A0 equal to 15. 15 degree. Because theta 0, at time 0, theta equal to 15 degree. So A0 equal to 15. So you get A0 equal to 15. Okay, velocity at theta time equal 0, velocity time equal 0, velocity equal to 0. So you get A1 equal 0. So to get A2 equal 20, which equation is easier to find? A2. To find A2, the equation, the easier way to find A2 by using, you need to solve between A1 is A0 A1, A2, A3. So you replace A0 equal to 15, and then A0 equal to A1, A1 equal to 0, A1 equal to 0. This equation, A1 equal to 0. So you get 2A2 and plus 2A3. This one is you replace A1 equal to 0. So you can use these two equations, and then use elimination technique to get A2. Okay, equation 1 and equation 2. You replace A1, you replace A0 inside the equation, and then you can solve it. You can find A2. But the easier way to find A2 is by using this simplified equation. This one. Okay. This is the simplified formula to find A2, because A1 you already get here. A1 you already get here. So you get already A1. So you get already A0. Now you want to find A2 and A3 by using a simplified formula. So A2 equal to 3 divided by T power 2 final. Then theta final minus theta 0. So for example, 3 time final is what? Time final is 3. 3 power of 2 is 9. Theta final is 75 minus theta 0 is 15. So 313 is multiplied by 3. So this one 75,007 minus 1 is 6. So equal to 1 over 3 multiplied by 60. So 3 multiplied by 20. So you get A2 equal 20. A2 equal to 20. Then you need to find A3. So A3 equal to, you can use this also using elimination technique. So to find A3, you can use this equation, equation 2 and equation 3. Replace all this A1 and A2 after you get the value. So you can use elimination technique to find A3. So the other way to find A3 is by use a simplified formula, this one. So you can use this formula. So A3 equal to negative 2 divided by T power of 3, T final, theta final minus theta 0. Okay, so now you can replace negative 2 divided by T final is 3, 3 multiplied 3 multiplied by 3 is 9, 9 multiplied by 3 is 27. So this one, final minus by theta 0 is 60. Hmm, 3 is 9. Divided by 3 is 20. Yang 327, nombor 320. So equal to negative 40 divided by 9. So what do you get? 4.44. A3 equal to negative 4.44. Okay. So once you get all the value of A1, coefficient with A0 until A3, so you replace this coefficient inside equation position, inside equation velocity, inside equation acceleration. So just replace A0, A1, A2, A3. So you get the equation here. To plot a graph, then you need to plot a graph. So to plot a graph, for example, you have 3 seconds. So 3 seconds, I recommend that you need to plot at least 5 scale. 5 scale. That means you have 2 scale at the left and 2 scale at the right. So 1 scale at the middle. So if you do only 3 scale, that means 0, middle is 1.5, and final is 3. So you will get is a triangle shape. Triangle is wrong. Actually, if you have more scale, then you will get a better plot. For example, here, if you put 5 or 6, so actually your plot is a shape of curve. It's not a triangle. If you put only 3 scale, so you only can plot a triangle shape. So actually you didn't get a true curve lah. So from this equation, after you replace A0 until A3, so you just replace your value of T. So for example, if T0, for example, this is equation for position. This is equation for position here. If you start at 0, time equal to 0, you just replace 0. So your answer is 15 here, because this is 0. If you have you use a 1.8 as a middle value, or 1.5, so you just replace your T equal to 1.5 power of 2, 1.5 power of 3. So you get the value and then you total up this. So 15 plus what the value here minus what is the value here. So from this, when you replace, you found that your position at 1.5 degree is somewhere here. Somewhere here. So if you have 5 value of time, so you will get a better curve lah, because you have 5 point here, so you will get a better curve. And then you use your velocity equation, then you replace with another 5 position of time, so you will get a velocity graph. The velocity graph. So this is velocity degree per second, and the x-axis is second. So you replace t equal to 0, t equal to somewhere here, the value, t equal to maybe 1.6, and then the last t equal to 3. So we replace this, so you will get a curve for your velocity. This means that at the beginning of robotic arm, without moving yet, so your velocity is 0. And after you move in the middle, your velocity is the higher value. At the final point or end of your position of your robotic arm, the value of velocity go back to 0 because your robotic arm is already stopped. So you know that at starting is a 0 velocity and the final position also 0 velocity. So your velocity will increase at the middle of the distance, middle of the distance. So between your position from starting to final, so your velocity will be increased to the maximum velocity between start or initial position to final position. At start and final, your velocity equal to 0. And then you apply your acceleration equation. Same, you will replace your time second inside your t value. So if you have 5 scale, that means you need to put 5 value at your time. For example, start from 0 and then 0.6, 1.2, and then get the result of your acceleration plot like this. So you will get degree per second square is your acceleration value. So you can see that here. At the middle, your acceleration is 0. It's about 1.5 degree. So that means when your robot move in the middle of the motion, so your acceleration is 0 here. So at starting and final, your acceleration whether smooth acceleration go to 0 or go to higher or go to final. So your acceleration will be increased as what we call smooth motion to your final or to your starting or initial position. So this is acceleration graph. So this is for single link of robot lah, single link of robot. If you have multiple link, so you have 2 joint or 3 joint, so your graph will be different lah. So you have another extension for the graph lah. So the equation here actually to find out this formula to find out your coefficient value. So once you have get this equation, for example, this equation, so you can put this equation into your microcontroller. So put into your microcontroller, for example, here to control your velocity. To control your velocity from 0.0 or initial point to your final point. So you will have a good control system lah, to control your velocity. So your control velocity will depend on your total time kan, total time from 0 to 3 seconds. So from 0 to 3 seconds, your time will be changed. Your velocity of your robotic arm. Same go to your acceleration. So your acceleration, you control your robotic arm is depend on your time. Starting to your final time. So when you put here, your time you go to what? 3 seconds. 3 seconds. So multiply with 26.6. So you will control your acceleration of your robotic arm. So this will be putting inside your robot controller. If you didn't have this equation, your robot become like a lot of stoppages. So it's not smooth, it's a lot of stoppages. So if you reach your final point, your motor will stop drastically stop. So that's why it's not smooth. So if you carry anything, a soft material, so your material will break or maybe drop out because you break your arm, robotic arm immediately. So if you tool, your arm is carrying any fragile product, so your product will break. So you need to move to control your robotic arm to make sure your robotic arm start and stop in a smooth motion. Smooth motion, that means you need to control your velocity and your acceleration. So the easiest way to control your motion by using trajectory planning. One of the method of trajectory planning is this cubic polynomial. This is another example. This example is similar to exercise 1, but you can see that this starting position is at 10 degree and end at the final angular position, and or that means your robotic arm stop at position of 90 degree. And then zero initial velocity. This means that your starting is zero velocity and zero final velocity. That means when your robot reach your final point, so your robot will stop. So stop means zero velocity. Calculate trajectory for the robot joint and sketch the position, velocity, and acceleration profile. So similar to the example 1, but you have different term of your starting and also final position, because in this case, example 1, we said that velocity, acceleration, and then function degree desired to move manner to the 75 degree from 15. Motionless. This one they use motionless. And then the final we call desire to move the joint smooth manner to 75 degree. Okay. But starting they call motionless. Motionless, that means start. Here, starting we call initial. Initial also means starting position. Final angular means final point. This is example 3, exercise 3. They use word to move from theta 2 30 degree to 150 degree in 5 seconds. Find the cubic polynomial generated the smooth trajectory for the joint. Assume that the initial and final. This one they call initial and final. Initial and final position ataupun velocity. So actually the task is similar, but the word they use to for initial and final, they use a term of word for initial and final is slightly different. Okay, this exercise is focused on cubic polynomial without viewpoint. And this is cubic polynomial with viewpoint. This viewpoint, if you have any obstacle between point 1 and initial point to final point, so that one we call cubic polynomial with their points. So that means you need to avoid the obstacle through a via point. For example, if this is your initial, this is your via point, and this is your final point. This one a little bit extended from the first one. So cubic polynomial with via point. If you understand this cubic polynomial, the first one, so you can answer cubic polynomial with via point, because cubic polynomial with via point is just extended the graph. We extend the graph. So that's mean we need to calculate twice. If you calculate here, half of the graph, if you calculate for cubic polynomial with via point, actually you calculate another half of the graph. So the formula stays similar. But your formula to find A2 and A3 will be extend. So you will use this formula, because you need to join your graph at your via point. Okay, example this question. We start from initial starting 10 degree position, and at the final angular position is 90 degree. That means 10 to 90. But you must go through via point 50 degree with 0 initial velocity and 0 final velocity. So initial 0, final 0. Actually the calculation is similar, but you need to combine another half of the graph into one graph. For cubic polynomial with via point, maybe I will explain later in next class session, because this one I have another example, more example using cubic polynomial with via point. I will explain later in next session of next class session. The important part that you need to understand is the cubic polynomial without via point. First, you need to understand this. If you understand the cubic polynomial without via point, to apply to cubic polynomial with via point is easier. I will share this slide later. And then I will share, but I will teach first a cubic polynomial with via point, and then I will share another slide for cubic polynomial with via point. So anybody still not clear how to draw the graph or not? This. So this is very important topic. How to plot from this equation to this graph. Kalau tak faham tolong tanya. Ada siapa yang tak apa clear lagi tak? Daripada graph position ni, graph position nampak degree, second. So that means your robot move how many degree per second, because your motion is between 0 to 3 seconds. So this we call position graph. So what degree, how many degree, and what is when you move your robotic arm in 3 seconds. So you're going to know what is the position of your robotic arm. This one, velocity, degree per second, angular velocity, degree per second. So this is second, this is degree per second, this is angular velocity. So that means, if here, that means this position said that your robot turn 30 degree per second. 30 degree per second at this peak of your graph. This one 0 degree per second, your robot is stopped. So this one also 0 degree per second, your robot is stopped. But this point, your robot turn at velocity of 30 degree per second, the maximum velocity. In between 0 to 3 seconds, so this is the peak point. So the highest velocity of your motion of your robotic arm. So it's smooth lah, because we use a trajectory to control your robotic arm to move in smooth motion. Same goes to the acceleration. So acceleration is degree per second square. So degree per second square, and then this x is a second. So make sure if you do your if this question coming into your exam, so make sure you show your value. You show your value in table. For example, you have 5 scale. So you have 5 value here. You put in table or what. So you show your value. Then you plot your graph. Ada siapa-siapa lagi tak yang tak faham macam mana nak plot daripada equation ni ke graph? Untuk calculation is easier. You can use this formula. You can use this formula to find A0 to A1 coefficient. So you use this formula. This one for cubic polynomial trajectory result via point. So you can use this formula. When you get A0, A1, A2, A3, so you can replace back into the equation velocity, position, velocity, and acceleration, and then you replace t value to plot a graph. Replace t value to plot a graph. Bolehkah?
Boleh, Doktor.
Bolehlah. Senang je ni. Trajectory paling senang sekali soalan. Soalan paling senang. So awak cari, find out equation. Find out A0 to A3 and then use back the equation. Replace your time, plot a graph. So you get your graph for your position, velocity, and acceleration. If you use this formula into your microcontroller, so you put this into your microcontroller, time, will be set at your microcontroller how many seconds you want your robot move from point A to point B. For example, from start to final, if you want slower, then maybe you put time longer lah, 0 to 10 seconds. If you want your robot move faster, so you put your time T is 0 to 1 second. So your robot move very fast lah, for example. But it's smooth motion. It's smooth motion. Okay, now it's 2:28. Sorry, because I'm starting late today. Suppose I can finish the cubic polynomial with via point because I have another slide example to share. But I will share it next week lah. Next week, Wednesday. After the trajectory, then we have another topic which is robot work cell lah. Robot work cell. Then we finish out our robotic subject. So now our last topic is robot work cell. But next week I will continue a little bit on robot trajectory and then continue with robot work cell. So finish your semester, your robotic subject for this semester. But your laboratory, you have 3. One is a robot today. Tomorrow also you have another one group, and Friday you have 2 group. So make sure maximum student that can enter the lab is 24 student, because we have equipment can support for 24 student per session lah. So today we have insufficient student lah. So I think maybe Friday or tomorrow little bit crowded lah. Anybody that didn't come today, so you can come, but you need to divide by yourself lah. For example, 24 student, you can come another extra student, maybe 2 or 3 student lah. Because today we have insufficient student lah. We only have about 5 robot. 5 times 3 is about 15 robot, 15 student only. So tomorrow maybe we can put more student, maybe 24. We put extra little bit, maybe 4 student per robot ke. So to make sure we can finish out our lab for this robot by this week. So next week we will start a new laboratory, is robot programming. Some students from diploma, they said they already use in diploma subject last time. So I hope that they can refresh back lah, using this robot, the system programming. For the new student that come from matric, so they are new on this programming. But Dubot is robotic app is new. This is a new robot. So make sure tomorrow our lab session start from 2 p.m. to 4 p.m. So make sure tomorrow. So make sure if you want to come extra student, please come, because this way we have insufficient student. If not, we need to find another time for that extra student. Lebih kurang berapa? 15. Lebih kurang 9 student kot. 9 student. Kena buat extra pula. Extra time. Okay, make sure tomorrow come 24 student lah. Or maybe 24 plus 4. So 28 student. So I still can accepted lah for tomorrow lab session. Ya, ada soalan tak? So 85 student ada lebih kurang 10 orang kot dah, tak main. Tak masuk. 10 atau 11.